talk about the register. So the first actually register that we make is going to load a 4-bit and keep that 4-bit in the register. So that means we want to make this. We want to have one 4-bit register. You consider something like this, which you have for input, right? So if you want to actually make some kind of the memory, so that means whenever you have some inputs, able to save that somewhere, that able to keep that 4 bits, and you are able to use that later. So that means I actually have x3, x2, x1, x0. So I want to use the flip-flop, make a register that's able to load these 4-bit and keep that 4-bit inside these register that you're able to use in the later time. Okay, so it is actually is very simple. So you actually use the 4D flip-flop. So I put D flip-flop. This is the first one. So this is a second D flip-flop. For actually each of them, you need actually one flip-flop, right? You put the third and you put the fourth one here. Again, this is D flip-flop, okay? So if you label whatever you keep here, you call that Y3, you call this Y2, Y1, and Y0 is the 4 bits that you keep inside this register. So I could say, okay, whatever I have here as the output of these D, this is the same thing with, yeah, we could say, yeah, whatever you put here, if you see this Y3, definitely should be X3. Okay, so this is actually Y3. So you give actually the X2 from the input of the D. Sorry. Okay. Yeah, so this is actually your, I gave the X here, consider output as a Y3, put these X2 here, consider as a Y2, put these as a X1 and consider this as a Y1, give the X0 and the output is Y0. So definitely you need, if every actually clock pulse has one, sorry, every flip-flop has a clock pulse. So the clock pulse that I use is actually the rising edge. So that's the reason I use these actually, this symbol here. So you connect all these clock pulse from 4 of them. Okay. And actually label that CK or CP, which is your clock pulse. So if I explain what's really happened here, so see the clock pulse actually has these actually square wave, okay? So I'm going to have one clock pulse here, okay? So this is actually the rising edge. Definitely I need to find the rising edge that's able to know where, when actually it's take a look to these inputs, right? So where is the rising edge? So definitely this is a rising edge. Whenever you move from 0 to 1, where is the next? Next is here. So where is the next? Next is here. And where is the next? Next is here, okay? So here I summarize the D table here. Just, we already explained about the D, but I put this D table that we already learned. So this is CP, this is a D, you have Q in time N, and definitely Q N prime, okay? So see how I'm writing this. If you back to what we learned for the D here, so in the D, whenever it is 0, it is actually the hold. Whenever that is 0 is 0. Whenever it is 1 is 1. This is a normal D flip-flop. But here I have the actually rising age, right? So this is actually the rising age. So this is rising age. So that means whenever this is falling age, falling age. I consider that as a rising age. So see, similar with we put 0, we say whenever it is 0, so it is actually it is don't K, right? Here, because this is falling age, I say whenever it is, sorry, because this is a rising age, I say whenever this is the falling age, should be hold, right? So that means Qn is Qn minus 1. Definitely prime of that should be Q prime n minus 1. So whenever this is a rising age, which is these two Ks, it's actually take a look to the D, right? So this is 0, you have 0, the not is 1. If this is 1, Qn is 1, and it's not, it's 0. So we call this reset because you have a 0, right? So here you get the 1, you call this set, okay? So the only difference actually between this table and the table of the normal D flip-flop, you just change with 0 to the falling age, and these two change to the rising age. Why? Because here, based off the sample that we use, this is actually the rising age. Whenever you are in this time, which is this rising age, it's actually take a look and see what you have, okay? Otherwise, they are actually just hold it, okay? So based off that, so let's see the circuit that we have here do the same thing. So for example, if you give here 1 0 0 0, so let I actually extend this. So whenever I'm here just to hold, whatever they already have, they actually keep that value. So I'm here, this is a rising age. I take a look, the flip-flop take a look to the D and see what is inside that. So if it is 0, so definitely you will have 0 here. So if this is 1, you have 1 this. And you hold that value, it's whatever you give here in this time. So between these two rising age, it's hold this value until you get the new actually x3 in this time, because in this second rising age you are it's actually take a look to the x3 and see what's x3, what is the inside x3, and put that inside the y3. So that means it's do exactly this, right? So I put the 4 different value here. So it's actually whenever you are in these rising age, it's low these 4 bit inside these register and able to keep these until when? Until the next actually rising age. So then in the next rising age, again take a look to here. Whatever you have inside this x4, x0, 1, 2, 3, it actually goes and load there, okay? So how you could tell, okay, I want to have the specific big pattern for the longer time. So definitely if you change the frequency of these clock pulse, somehow you could tell how long it should be stay inside these actually the register, right? So for example, if I give the period of here to here is 1 second, because you could change the frequency of that, right? You know the relationship between frequency and period, right? So 1 over t is 1 over period is frequency. So if here is you have 1 second, so that means the frequency is 1 over 1, you have 1 hertz. So that means it is load the value, but there is no change, and keep that for it until the next rising age, which is 1 second. So that means 1 second, there is no change here. So after 1 second, again, check what you have here. If you change these x0 to 3, it's changed and load the new value. If you don't change that, it's still able to keep that actually for until the next rising age. So that means just in this rising age, it's actually check the value, whatever you have here, load inside this register, it's keep that until the next rising age, which is again double check the input and see what you are giving. Somehow this is the memory, right? The register is some kind of the memory. You are able to keep these bit pattern inside this for location. So I actually have one simulation for that, which is maybe help you to understand better. So this is actually is exactly the same circuit, okay? So whatever you see here as a x0, this is x actually 3. So see, I put just one switch here, which is this one side of this switch connected to the ground, the other side is 1. So that means whenever I change this switch here, this input is 1. So here, whatever you have, this switch, you are changing the value, the input value of D, okay? So if I back to my design, so I put the switch here, one switch here for x3, one switch here for x2, one switch for x1, and one switch for x0. Why I did that? Because I want to able to give 0, 1. Whenever I want 1, just change the switch, I'm able to load 0, 1 for any of them, okay? So that's actually the switch that you see, each of these inputs here connected to switch. So this one, this side is 0, the other side is 1. Okay, nothing new here. So see the clock pulse. This is one clock pulse. This is second clock pulse. This is a third one. This is the fourth one. What I connected to the function generator. Why I did that? Because I need a square wave, right? So see a square wave. I have a square wave. So that means I'm giving the square wave. What's the frequency of that? Is 1 hertz. What's the duty cycle? Is 50 hertz. So what's the meaning of the duty cycle? Duty cycle means the time that you keep 50% duty cycle, means the time that is high is exactly the same with the time is 0, right? So if I back to the node, so that means so here to here, which is the time it is high, is equal exactly with the time it is low. So these, whenever this is exactly same, we say duty cycle is 50%, which is somehow you make the centric actually pulse, right? So that's what I put 150. So the rest is it's not important. Amplitude is 4, offset is 0. So that means here I make one square wave with the frequency of 1 hertz. Okay. So see what's happened. So what you expect, I actually start to simulate that. So whatever I put here, it should be load inside this register, right? I also put the indicator inside for the output connected to the indicator, to the LED. So whenever this is 1, this LED is on. Whenever the output is 0, it is 0. So what you expect right now, this S is 0, the X3 is 0. So that means X3 should be load inside this, right? So if this is 0, I load the 0, it's keep the 0. If I change to the 1, so see, this is 1. So this is 0, it's off. So this is actually I change that to the 1, it is actually 1. So if I change that to the 1 again, you see it is 1, okay? So do you know what is the cool things about this is the frequency. So that means whenever I change x3 to x1, how long it should be takes you have the new value here. So see, this is connected to the 1, which is you see the 1. I change this to 0, just take a look to this LED and see it is changing immediately from 0 to 1, or there is a little delay. So see, just take a look to this LED that you see. I move from 1 to 0. See, it looks there is a delay. I'm doing the same thing. So see, again, this is 0. Right now it is connected to you just take a look to this. So right now it is 1. So that means whenever you have 1, again, I put these here. So it is actually you could actually feel, if you do yourself, definitely you could feel there is a delay. Why we have that delay? So delay is exactly this delay that you see, this time between these two. So that means here I give x3, it's get actually 1, it is 1. So then whenever I here immediately change that to the 0, it's not going to be immediately 0 because it should be wait these 1 second, then it's actually take a look, it's okay, it's changed it, it's changed the value. We could do that actually more delay. So how, you tell me how I could actually increase this distance that you have between these two rising age. Just type on the chat box and tell me if I want to have a bigger time interval between these two rising age, what I need to do in this simulation. What I need to do. Definitely. So that means the frequency is a key point. That means you need to come here. Okay, I want to increase that. I actually, if you want to actually have a longer period, so that means you should need to have a smaller frequency. So the previous one was 1. I'm changing that to 0.1. Okay, 0.1. So let me see, could we change that here or it's not accept that? Yeah, somehow we need to put actually on hertz probably. Let me see it's accept that or we need to change the, yeah, it's okay. So I put 0.1 hertz. You tell me if I have the frequency of 0.1 hertz, what should be the period between two rising age whenever the frequency is 0.1? Yeah, 10 seconds. So see, you say what I did, I actually put this 0.1 equal to 1 over t, right? So this is 1 over 10. So that means t is 10 seconds. So that means right now here to here is 10 seconds. So that means if I give 1, so it's actually is on. So whenever I immediately turn off, it should be still on for 10 seconds. So after 10 seconds, whenever it see the second rising age, it's update the value, right? Let me see, could we see that delay there? So I actually okay that. So back here in simulation. So see, right now I'm in the 1. I'm changing that to the 0. So see, it should be take time. It should be 0. Yeah, it should be take 10 seconds. So let's see. Yeah, see, yeah, definitely. That's actually cool. So see, right now this is 0, this is 0, right? So whenever I actually put this on, it's not going to be immediately on because it should need to wait 10 seconds to see the second rising age, then actually update the value, right? So that's what actually happened here. So see, I'm in 0 right now. I'm changing to the 1. It's not 1. So see, it should be take actually 10 seconds. Yeah, see, after 10 seconds, it's actually able to see that actually change or update that value. So see, again, arm here is on the 1. So then I'm changing that to the 0. There is no immediate change to 0. It's take a time to see the rising age. So after 10 seconds, it's actually see the rising age, right? So similar with all of them. So see, whenever you play this frequency, you exactly see it. Take a time. So here I change to the 0 to 1. So again, I immediately change to the 1. So see, it's not immediately gone. It's wait to see the other rising age, then check the new value and change the value. So same for all of them. So see this, again, you change that to the 0, so it's take time. So you could actually play with this. So see, you right now you see that delay, so let's to change that to the actually more faster frequency that you don't have that delay. That means immediately it see the rising age, update the value. I change that to the 2. So right now it should be somehow, I shouldn't feel that delay because the TS is very small. So see right now, whenever I change, it's actually changing very fast. There is a delay, but the delay whenever the frequency is 2 is 1 divided by 2 is 0.5 second, which I really couldn't feel, right? I feel whenever I push that immediately change, right? Even if there is, you could feel a little that 0.5 second, but it looks very short time and it's immediately get that value, okay? So this simulation actually give you a better idea about the clock pulse, or how clock pulse actually works, and how you are able to change the frequency of the clock pulse, right? So that's what we have here as a register and loading the register. So see again here, if you want to load any value and keep that inside some kind of the memory, so the register is right. So see right now I want to actually keep 111. So see, I actually keep this. Yeah, to see where it's, yeah, see, I put 3-1. So I have that value save inside this, load inside the register and save here. And whenever I need, I could back and read this. It could be a data, right? So that means the data is a bit, right? I keep these data inside this load register. This is actually how the register works and how they are able to keep the data or information.